Hello, I'm Derek Seckinger with Frost & Sullivan. I'm joined today by Roberta Gamble. Hello, Roberta.
Well, thank you. It's my pleasure for being here.
Well, Roberta, I guess the first question is, what exactly is smart infrastructure?
So, smart is the new green. It's going to be facilitating our lives in several ways. It's a way to conserve energy, it's a way to create greater efficiencies, and it's really a way to promote safety and security. When we talk about smart infrastructure, for the purposes of today's discussions, there are four major areas to look at. There is energy, there's the environment, there's telecommunications, and critical infrastructure. So starting with energy. Smart energy really pertains to the spectrum of energy, from fuels to generation, transmission, distribution, and even through to consumption. On the environment side, smart usually refers to water and emissions controls. In telecommunications, we're talking about internet, talking about broadband, and so forth. And critical infrastructure are the roads and ports and railways that we need to monitor and keep safe. But in all of these areas, the overarching theme is that smart maximizes productivity, it reduces losses, and it overcomes security issues.
Okay, well, with regard to energy, what are some of the key challenges you're seeing in this industry?
What may sound like an obvious but a very important challenge in the industry is just the demand for energy. And energy demand is growing in two ways, by sheer population, but then also the amount of energy being used per person on a global basis as we have an increasingly urbanized and middle-class population. Now, this is going to require innovation from both consumers as well as from suppliers. Now, from the generation angle, your challenges include legacy plant systems. Your average coal plant is 35 years old in the US. You need to be able to operate them efficiently, more cleanly, reduce effluent discharges, and so forth. There's just not enough ROI to justify a rip and replace of critical assets. So from the design engineer's perspective, the ability to take advantage of standardized systems and monitoring data and other electronic equipment that may be exposed to harsh conditions is important to enabling communications with all the disparate assets on site and to improve energy efficiency. So if you're going upstream a bit and looking at gas production, the emerging opportunities in shale gas are tremendous. But there's definitely a need for on-site advanced measurement. So that enables efficient communication to monitor and document environmental as well as emission requirements, and just to dispatch the gas from the wellhead through the rest of the value chain. The industry needs compact, ruggedized, open systems with the ability to communicate with other proprietary systems. On the renewable energy angle, the main challenge there is you have solar and wind power in remote locations, and you need to be able to communicate across vast distances. You need systems that can protect against the elements and diverse conditions, and they're just better able to manage, monitor, and service those assets. Now, as you look at the grid, in transmission distribution, the main focus there is smart grid. So you have open standards and standard-based systems that move energy from where it's being generated to where it's being used. Demand on the US grid is immense, and we've all seen the significant negative effects of energy spikes and brownouts. So you just need to be able to monitor and handle those irregularities and just handle the sheer amount of data that's being collected on the nation's power grid. Now, when you move into the consumption side of the equation, we see industry increasingly participating in demand response, looking to load shedding, load management. In this instance, design engineers need to grapple with the challenge of data monitoring and control. And here they're also dealing with legacy systems, with diverse interfaces, and optical connectivity, along with other issues.
Okay, well, considering smart infrastructure, what are the challenges you're seeing in other sectors?
So if we look at data centers, for example, a major energy user and a critical element in smart infrastructure, device complexity is increasing. Servers can store an increasing amount of data in the same space, and form factors, such as blade servers, mean more equipment can fit in the same space. That creates a lot of heat. So the ability to handle thermal gradients and have smart design is really critical. Also, overall, these requirements are increasingly global in nature. So you have these volumes of devices used and monitored, which can vary, and then the diversity of them is immense as well. So you need a system that can manage and monitor a wide range of functions and across a diverse infrastructure. You also need to consider regulations, local standards, combined with the need to provide global support for products in which in industrial and infrastructure spaces have very long life cycles. A key best practice would be a solution that meets global support, diversity, documentation, compliance demands, and really is a paradigm relationship shift in the industrial space. So you're going to move away from vendors as just vendors. Vendors need to be partners. Partners that provide global support. Partners that provide DBASA, design anywhere, build anywhere, support anywhere. And design and build, in documentation, in understanding regulatory requirements. You need these technology partnerships that are going to cater to all of these diverse needs. And really, thereby, you're also increasing the speed of innovation on a global scale, nonetheless. So I think this will be the primary significance going forward.
Thank you, Roberta, for your insights.
Thank you. I was glad to be here.
Be sure to check out the other exciting videos in this series. I'm Derek Seckinger from Frost & Sullivan, signing off.